Okay, hello everybody. We're going to have a look now at some more rules. Let's try and derive another one using the information we know about triangles. So let's go back to our regular scalene triangle. We know that we call the angles capital A, B, and C. We know that we call our side lengths A, B, and C, but lowercase, and they are opposite the same letter angle. Okay, so again, we can start this little explanation by imagining we have a height, h, and we can try to derive expressions for this height. So if we imagine the left-hand side, right, well, we can use the sine, SOHCAHTOA, okay, sine is opposite over hypotenuse, and we can try to derive something using the angles and letters there. And if we look at the right hand side, we can do the same thing with the angles and letters there. So on the left, we could say that h is going to be c times sine of a, right? That's the opposite. H is equal to the hypotenuse c times the angle a. On the right hand side, we can do exactly the same thing, but using those letters and angles as well. That h is going to be the hypotenuse, which is a, multiplied by the angle or the sine of the angle, sine of C. Okay, so that is just using our right angle triangle formula to get those two things. So if h is equal to both of those two things, well, they must be therefore equal to each other. So surely we can say, if we've got two expressions of h, that c times sine A is equal to A multiplied by sine C. So from there, if we sort of move things around, divide perhaps both of these two expressions by sine A and sine C, we're going to find that C over sine C is equal to A over sine A. And if we could flip that round. If that's going to be true, then we've got other versions of this that are going to be true as well. We could rotate that triangle round. So the A was where the B was, and the B is where the C is, and the C is where the A is, and derive the following. We could say, therefore, that A over sine A equals B over sine B equals C over sine C. They're all going to be the same. And this is the thing to remember. This is the sine rule. Okay, now this version of the sine rule is really useful for finding a side length. But there's another version. We could, if that's going to be true, well, we could flip each one of those fractions over, and that is also going to be true as well. We could certainly say that sine A over A is equal to sine B over B, which is going to be equal to sine C over C. Now, this is another version, and this one is good for finding an angle. Okay, so look out for both versions. Just invert it to find an angle and keep the lowercase letters on the top when you're trying to find a side length. In the next video, you're going to see some examples about how this is used.